Good morning, everyone. Thank you for being here for our last day. Our session will be today on coastal management strategy and policy frameworks. And we have 5 talks from ECOPs showing real case examples of innovative management practice and policy. So, good morning also to the online people. And we will start with Anwisha Ghosh, who will present Voice of the Locals, the changing landscape of the Sundarbans. Thank you.
Before you guys get tired of seeing me. Thank you very much. Not up yet. Okay. It's just a photo, no videos of tigers. All right. So today's talk is titled as Voices of the People, the changing landscape of the Sundarbans. And what I'll try to show you is how the lives of the people are being impacted by the rapidly changing landscape. So for anybody who might have missed my first talk, that's India. And this is the Bay of Bengal, with the Sundarbans being located here. So as you might remember from my first talk, we have 3 major rivers: the Ganges, which flows through India. You have the Brahmaputra, which flows through China and then through India. And you have Meghna, which flows in Bangladesh, forming the delta of the Sundarbans, which is shared jointly by India and Bangladesh, about 40% of it being in India. So, all right. So in the Indian part of the Sundarbans, we have 7 major estuaries, and these are macro-tidal in nature. And you will see vast stretches of forest connected by the rivers and creeks, which is why there is a very high biodiversity in this region. And you have a tidal amplitude of about 7 meters coming in twice daily. So a lot of the biogeochemistry is controlled by the tidal energy in this region. So you see how the tide comes in. So what we also have is characteristic mud floods that stretch for kilometers at a length. And these are extremely anoxic in nature. So the only oxygen that gets into the sediment is by bioturbidation of crab actions. So you have these fabulous looking crabs, which people actually love to eat as well. But the sediment here is extremely anoxic, essentially promoting only methane and sulfur to be used as electron transport, the final electron acceptors. So what has been happening is that you have a very high rate of erosion, so much so that we don't know which part of the Sundarbans are getting lost. As you can see here, vast stretches get washed away by the river, but you have a very disproportionate sediment erosion versus sediment accretion rate. So there's some parts of the Sundarbans which are growing very rapidly versus other parts that are getting lost. But what has also been happening is that our upward supply of freshwater has been dwindling very rapidly. As a whole, the entire region is becoming more and more saline through the days. So we have some projections, and as you can see, unfortunately, by 2100, we think that we'll be losing our entire forest stretch. So in order to validate that what the projections tell us is accurate or not, we now have the RSET installed in different parts of the Sundarbans to get empirical data of how much soil erosion is happening or how much sediment erosion is happening versus how much is getting added. So we get exact values from these RSETs. For anybody who doesn't know what an RSET is, it's essentially rods that we embed in the sediment to measure how much of sediment has been added or lost with an annual cycle. So I'm just going to let this play.
Countless villages lay on the edge of the northern boundary of the Tiger Project. People regularly ventured into the forest for fish, crab and honey. The forest department permits local fishermen and honey collectors to work only in a certain part of the forest.
পশ্চিমী ঝঞ্ঝার দ্বারা তৈরি একের পর এক জলীয় বাষ্পের দেওয়াল কোথাও না কোথাও এই উত্তর পশ্চিম বা পূর্ব উত্তর ভারতের কনকনে ঠান্ডা
3 crab hunters are trespassing into the forbidden part of the forest secretly, avoiding the surveillance of the forest patrol. This tiny oared boat is their kitchen, come dining, come living room for the next 8 to 10 days. They're casting their thread lines right by the edge of the forest. Crabs collected from the last night's lines are then collected inside the hull. They are fully aware that most of the people who die from tigers' attacks are crab hunters.
Happens is that a lot of the changes that we see here, we have to find a way of translating it to information back to these local villages that it becomes effective. Otherwise, it just stays in literature and doesn't help the community. So that's something that we actively try and do in Sundarbans. And this is my last slide wherein you can understand how working in this ecosystem is extremely difficult. But we try and collect as much data as is possible for us to collect. Our projections, unfortunately, say that we are on the path of losing these mangrove forests, and even the big mangrove trees cannot stop the river from washing away large chunks or from storms from entirely doing away with big islands. But we are trying whatever is possible from coordination between the scientists and the local policymakers to see how much of this ecosystem we can save. Thank you for listening to me.
Thank you very much, Amisha. We have time for a few questions. Any questions from the audience? Yeah, Nadia.
Thank you. I mean, it is really our obligation to try to save this area. One question is, in your projections, what is the damaging, what is the parameter or the, let's say, the process that most damaging your area?
At par with the global projections, the Sundarban region has the highest rate of sea level rise. But what we have also found is that the tectonic plate on which India sits is really sinking. So that's adding to the land going down because of the tectonic movement, and at the same time, more water coming in because of sea level rise.
So land subsidence
Yes.
and sea level rise.
Yes.
Okay. Thank you.
Yeah, I was wondering about the crab fishing. If like what area? It looks like they target right along. But can you tell us more about the area that they target and what their kind of the region of interest for that fishery?
Okay. So if you look at this, sorry, it's not up on the screen. Yeah. So these are the most anthropogenic parts of Sundarbans. So more people, and you have lesser crab population on this side. These are the core forests, which is where the fishermen now move from these places to go inside, because they think that the more they go inside, the tastier the crabs. And also they have seen a sharp decrease in crab abundance in all of these regions outside. So they don't really collect much, which is why they are forced to go more inward. And they use these really small boats, which are also, to be honest, the boats that we use for our research purposes, because these are such shallow waters that your research vessels will not go in. So you need to get into a very small boat to enter into the creeks to do any kind of collection. So from the video I showed you are essentially these very deep forest paths which they now do collection. Because the crab that they catch there is bigger and they get more market value.
But it's like right along the roots. It looks like it likes the roots.
Yeah. So all of these green portions that you see is the reserve forest. and the tiger area. So ideally, you're not allowed to enter, but it's next to impossible for the forest department to keep a vigilance on such small boats. There is no tracking device on any of these. So it's impossible to figure out when somebody has gone into a creek, which is not allowed. So now, with the tie-up with WWF, what we have done is we have netted parts of the forest to not let the tigers come out, but really doesn't help because they find a way and then people move these nets to go in. Because another thing that is very widely popular in India is Sundarbans honey. Okay, it's absolutely unadulterated, and people prefer to have the honey from Sundarbans versus the commercial honey. So a lot of these villagers actually go into deep forest to collect that. So honey from the mangrove plants is more beneficial apparently. So that's also a very booming industry, forcing people to get into that trade as well.
Thank you.
Another question. So this bioturbation to bring some oxygen in or whatever, we have, we have other animals that do that in our areas, like worms, and so would it be a potential solution to increase the number of crabs, or how efficient is this, and is there a dominant species that would probably you have a multiplicity of species, which is good. So if you increase one species that is particularly efficient to bring oxygen down, would this be, how can we manage a conceptual experiment, a Gedanken experiment, where we think about all the parameters, and have people started to think about how nature-based solution for crabs, let's say, for revitalizing this low oxygen sediments?
So I think a reason why the area is also low oxygen is because it's silty clay, so it kind of sticks together, and the water movement kind of forces the sediment to be very sticky in nature. But in parts where we have actually done restoration, we have not applied any additional crabs or worms, but we've put in the trees, and we've seen that with the mangroves growing, as the pneumatophores pierce up the sediment, that brings in some success. It also brings the meiofauna and macrofauna back into the ecosystem, but that has not rendered the sediment toxic. We have not seen a change in oxygen levels in the water. Yeah, but this region does have a pretty high abundance of nematodes. So I think that some part of the action by nematodes also help in mixing of oxygen and nutrients in the sediment, but I don't think that's significant enough to show up anywhere. And as for applications, to be honest, as you've seen, that these areas are extremely difficult to reach, and you have when you're moving in small boats, it's difficult to carry things along with you to actually do any ground level experiments. And since this is a part of the reserve forest area, there is a lot of permits that are required in order to test anything on the ground. So whatever we do is still first allowed in the parts where there is human habitation. And then if that works, then forest department takes it up through it themselves.
No, sorry. So the other thing I want to make a suggestion. We need to preserve the big animals on the earth. Can't be only men, the big animal, right? So preserving tigers is also a good thing. And if that would cost to convince the population that they can buy commercial honey, will it be something to be done as an action? Because, tigers are important elements in our ecosystem, as all the big animals, and we are all killing them because there is some rivalry between the men and the big animals, right? So I hope we can discuss also this.
Yeah.
Thank you.
Sorry, we have to move on, but please, yeah, find Anvisha during the break. Thank you. Thanks again. And we now move to the next presentation by Nikia Going, who will talk about coast resilience with insights from Trinidad and Tobago.
Hi everyone. So because of the time limit, I am only focusing on a few elements of things that we're working on towards coastal resilience. So I'm not going to be covering anything to do with our Marine Data Hub, which is a spatial repository of marine data from Trinidad and Tobago. If you have any questions about it, though, I'm happy to answer. I'm also not going to talk about the oil spill detection program that we have, but if you have any questions about that, I'm happy to answer after as well. I really just I'm focusing on natural kinds of impacts and processes. Yeah, so the Institute of Marine Affairs, we conduct marine and coastal environmental research towards policy formulation, implementation, and decision making. We have a number of research programs. It is a multidisciplinary research institute, and in most projects, we all work together. The Institute is a state agency. However, most of our research is funded externally. So this is a little bit about Trinidad and Tobago. We are a large marine state in respect of the sovereign waters that we have jurisdiction over is much larger than our land space, which often means there's a lot of competition for land space. For example, this is one of the areas where there's often human intervention that is not always backed by science to try and prevent coastal erosion. This area used to be called Coral Point. As you can see, it's now Coral Bay, and that has happened on a magnitude of a lifetime and less. It has always been an area of high geomorphological change. As you can see from this very old image, old coastlines from 1906 to 1980, where again you can see quite a vast amount of land extent loss. And I mean, it might not seem like much to you, but in a country like mine, where we don't have much land space to begin with, when you're losing a magnitude of tens of meters over months, it adds up. So coastline change detection is something that we do pretty often, whether it is for the whole country, to give an overall view of priority measures that need to be implemented to inform whether it's nature-based solutions, coastal equilibrium, or even just assessments towards coastal vulnerability in communities that live nearby. Through the Coast Predict pilot program, we are going to be updating our coastal vulnerability indices, which include things like coastline environmental vulnerability, and that is towards natural and anthropogenic impacts, as is usually classed by geomorphological characteristics as well as social pressures. So there is a need for sea level rise and storm surge modeling data, simply because we do not have ocean observational instruments deployed in Trinidad and Tobago for any long period of time unless it's by the private sector. We are not able to work with our oil and gas industry players as much as you'd hope. So even though they have a responsibility where they are supposed to be doing certain monitoring, it is not something that is really enforced or implemented. And so it makes it kind of difficult for us to even know what exists and what data they collect. There are some companies that try to exercise their corporate social responsibility, and we've been able to get sponsorship for some projects. So like we have a coral reef restoration project that is being funded by BP. However, still not really getting any kind of access to the instruments, the expertise, or any of the data that they collect through their operations. Not only to mention that they are also, as most oil and gas companies in Trinidad and Tobago, they are slowing down their exploration and production. The storm surge is of particular interest simply because as you know, with climate change, you have tropical cyclone activities that are becoming more frequent, more intense, and they're having more and more devastating impacts. The impacts and the pathways typically for tropical storms and hurricanes in my region don't usually impact Trinidad and Tobago because we're so south, but now it is. So now every year we have at least 1 or 2 storms and even hurricanes that pass through. The other thing that we use a lot of Earth observations for is our ecosystem-based management. It's very important to inform any restoration and rehabilitation activity. Of course, it's very easy to be like, oh, we'll just go plant mangroves. But if you don't have an understanding of the environment, then it's not going to make sense. If there's nutrient pollution, it does not make sense. If the environment is just going to wash away all your nice mangrove babies, it's not going to make sense. And so it's really important to understand what is causing fragmentation, what is causing dieback, what is causing that loss and that change over time. I've also included the seagrass extent here because we've been able to not only map our seagrasses to the most precise measure, but we're also taking it a step further. We're doing density measurements from satellite observations now. The other thing that we are doing to help to really control our conversation with, why do we need to conserve and preserve our coastal resources is through blue carbon quantification. So blue carbon has become a very sexy thing. It's very trendy, and it's very easy to get research funding for. But it also really helps because, as I mentioned, we have a lot of competition for land space. In the Caribbean, often forest is cleared for things like resorts and high-rise buildings that we really don't need. So, this helps us to really make that push towards, and then also for us to meet our regional and national requirements for reporting as we are part of several climate change and ecologically based treaties. So what we've done in Trinidad and Tobago is we've developed a methodology using terrestrial laser scanning. So that's the weird thing over there. It's become a lot easier to use very recently because they're way more portable than they've ever been. And as the last speaker was talking about, you have to often use small flat bottom boats in mangroves, which means you can't take a lot in. And so to have these kinds of things that could just fit in like a little laptop bag or a little tote, it's about 5 pounds. It also has a carrying case that protects it in case you fall in the mangroves, because that happens often. We're able to then deploy it and recreate the mangrove forest in 3D. And what that helps us do is it helps us to quantify our physical feature of the mangroves that are typically left out. Traditionally, mangrove stock carbon assessments have been done just using airborne LiDAR and just satellite imagery. If we do that, then we don't get the very intricate root system that exists with the Rhizophora mangrove in my country. And that has been a huge underestimation of the amount of carbon that can be stored and sequestered. And so it allows us to also get into that conversation towards financing and mechanisms for trading that helps us to now, show the government the dollars and the science that they've always been asking for. And we've also been able to share this methodology with a number of countries in the region, and we'll continue to do so. And then the other thing that's been a huge challenge recently is the realization, or I'm calling it realization because more and more people are being impacted and they're seeing the face of climate change. And for some people, the first time that they've ever really been affected by the impacts. Whether it is the glass bottom boat tour operators of the coral reefs or the fisher folk that are being impacted by the decimation that is being caused by the marine heat waves. So the aspect of management with coral reef bleaching that is becoming more and more difficult to manage is not just the lack of support from government sometimes when you make a recommendation after a bleaching event, but also because bleaching tends to make them quite vulnerable for diseases. So Trinidad and Tobago is one of the few countries in the region that have not had any kind of sighting of a very damaging disease called stony coral loss tissue disease. It is a disease that has been killing a lot of coral reefs in the region, but we've not yet had it. So right now we are kind of like on the lookout. Some of my colleagues who are coral reef ecologists have received training, so they know how to manage it when it does, because it's not a matter of if, now it's a matter of when. We've reached that tipping point, so they're just kind of looking out, especially because of how bad the marine heat waves have been. The other thing that we've been starting to measure just through our wetland management is saltwater intrusion. And the reason why it's only through that is simply because that's the first thing that tends to respond. So it's one of the measurable impacts versus, just the change in erosion or sea level rise. And as I mentioned, we don't have very reliable sea level rise data to begin with. The next thing that we are dealing with in our coastal environment is the huge waves of sargassum that's been washing up over the past few years. The sargassum season has expanded, it has intensified, it is more often, it is a public health crisis, and so the detection and forecasting of it is particularly important for a number of different industries: fisherfolk, the marine shipping, transport, tourism, recreational, public health, as well as the management of our marine life, because it affects turtles. We have one species in particular in Trinidad and Tobago that nests a lot, called the leatherback turtle. It is endangered, and we have the highest population that nests and forage in our waters, and their turtle hatchlings are often impacted by sargassum. And some of the things that we're moving towards in the future is more monitoring of general ocean health through development of a water quality indice that is going to be measuring towards applications for ocean acidification, coral stress, eutrophication, and HABs. HABs is an area that is understudied in the region, and it's simply because there's very few of us and we don't have time to do everything. But also because some species are like on our radar and some aren't. So the species that tend to affect our economically viable fishing, that is on the radar, but other species that might affect like seagrass is not. And so it's really just a matter of resource allocation towards starting to monitor and measuring the presence of these harmful algal blooms. And yeah, there's a general need, as you might know, for trajectory modeling as well for the sargassum, for the oil spill, and even to understand our nearby ocean currents. That is going to be very important to monitoring any kind of ocean health parameter. That's it. Thank you.
Do we have questions?
Hi, thank you for the presentation. I saw a lot of work and effort, actually incredible effort for monitoring and measuring a lot of different situations and environmental crises that you're facing. What would you see as a favorable solution, or maybe a set of solutions in order to face the problem, if there is, and if there are some scalable solutions, which doesn't mean the big solution that can solve every problem, but like a huge impact that can, a huge process and action that can be done?
I think one of the things that we've been able to build a very solid base for locally has been the use of spatial intelligence to inform action. So I think that is pretty much covered. What I would say to scale towards things that we have the gaps in would be the trajectory modeling, would be the oceanographic and coastal modeling. And that's simply because we've been able to leverage already spatial intelligence for so many different actions that there is no kind of doubt about the merit and the utility of using oceanographic data. And that is going to be very easy to uptake and to put into decision making. So it's really just about filling that gap so that then we can make further, informed decisions. And also because I believe the Institute is in a very unique juxtaposition. It's easy for us to do outreach. It is easy for us to share resources and capacity, whether it's through conducting workshops in the region or helping students. I guide a lot of students in their research. And so I think just filling those gaps will be able to empower us to do even more, and more in the region as well, because we are a regional activity center for a number of things. Yeah. Yes. You're welcome. I hope that answered the
We have
question.
time for one other question. I think you raised first.
Yeah, thank you. I was wondering, so I'm not familiar with the some method that you mentioned with the lasers. You know, it's not in my typical conversations scientifically. So, what do you learn from that activity and has it helped you beyond the satellite information to kind of figure out why the mangroves are moving more, or how does it help you towards that question? Yeah.
Okay, so the terrestrial laser scanner is an instrument that is based on LiDAR. So very simply, as you know, LiDAR can be an instrument that, if you imagine the glass and you imagine the microphone as the instrument that is emitting that laser, it's going to shoot out thousands of laser points towards the object of interest, the glass, at a rate of thousands per second. What it's then doing is measuring the return or the reflection of that laser as it returns to the instrument. And that is going to give you, through the measurement of time, distance. Through that distance measurement, it's then able to recreate in 3D. Aerial LiDAR is what you would use to create things like DENs, DSMs, DTMs, and it allows really for a great understanding of things like the possible outflows or, well, water flows in a mangrove environment, for instance. So it's really helpful for hydrological assessment. When you have the ability to take LiDAR from something that's usually just attached to a plane to something you could take into a mangrove environment where we lose all the time everything in the canopy, so all the branches, and then we lose all of the roots, it helps us to now encompass that in biomass estimations, which help towards the carbon sequestration, storage, and sequestration. We've also done a lot of mangrove soil assessments because, again, that is usually just gathered by like satellite imagery through extent. But what we've been able to prove is that mangroves store anything from 4 to 7 more times than our tropical rainforests. So it is even more important to preserve than the tropical rainforest. And in many instances, it's not allowed to retreat due to things like sea level rise because of coastal squeeze. Our urban environments are very nearby. But yeah, so the TLS, the terrestrial laser scanner, just allows us to have a better estimate of and a better measure even for different morphological or phenotypical changes that you might want to monitor for ecological health in a mangrove forest. You're welcome.
And we now move on to our next presentation by Matine Yucharun from Faculty of Environmental Management in Thailand. And she will talk about tropical ecosystem resiliency, southern Thailand to ocean change.
Thank you, Loretta. If I'm running out of the time, just poke me. Sorry. Okay, hi, everyone. That I think you already know I'm a biologist, which is, people here is like quite so totally different from my view. But I hope my presentation today is can give you a view that you can fill any gap of your framework. So I'm from the Oceanography and Climate Change Research Center, which is actually, it's not that big. It's under the university. And then I can just put here, okay. We have 5 campuses on, it's the southern, local southern of Thailand, and you have, it's quite far from Bangkok, that the Anukun place from Burapha University is close to Bangkok and in the Gulf of Thailand. If you see here, we have both sides of the sea, which is the part of the Indian Ocean connected, and another part in the South China Sea, which is totally different of the condition. Like the South China Sea is quite shallow area in part of the Gulf of Thailand. I think the most maximum depth is not more than 100 meters, right, Anukun? Yeah, it's quite shallow, so we only have the coastal habitat, which is distributed along both sea, coral reef, seagrass, mangrove, and also we're facing of erosion problem along the Gulf of Thailand also. Okay, this is just of my team that we used to have the social science, but it was a pity that she already retired. She is a senior, but we are trying to work and transdiscipline to integrate our work of we have geologists, chemists, and the guys that are doing pollution, and we have only one data scientist, which is very hard work for him to deal with the big data and remote sensing. And we have mostly biologists of plant biologists and me as a coral biologist, more deep into physiology, like mechanism inside the corals. So yeah, mostly of our work is on the environmental science, really science, but we would like to use this side helping the government to direct. Then mostly our work is a research that ground truth data and the institute data that I choose two of the project of my team to share here. That what we ongoing to do that since the past few years ago until now. To it's not that from only one funding, but what we are trying to do that because I think in our region or maybe is the global problem of the budget and what the people share about the restoration habitat that is the missing of the direction of the only come for distribute money and just for transplantation, and our costs have changed along the time. And since Anukun mentioned that the land changed from the mangrove side to aquaculture and then restore again, and then only one or two species that regenerate very fast growing, something like that, to make like fast output. So we try to do the research that high impact with limited of resources that what we have in our hands, but that we another part is engaging of community, because they actually realize how important, I mean, the local fishermen or the community, the habitat in front of their home, because of that is their life. But the thing is that the industrial between both parts is not that easy to communicate, so that we are also trying to do that. So sometimes we also try to chasing the funding from industrial, like electric authority, something, and then try to make an evidence to let them realize what is the fact of science, and use this science to direct them for whatever you want to distribute the money. Is that worth for the habitats for the people or not, something like that. So this is one project that about the blue carbon. Yes, it's a sexy keyword, of course, and then we can get the funding, but that is a good chance. But that we also try to simplify the data for people. Like in the part of science, we try to collect the carbon sequestration with the natural habitats, also compare with the planted. But you know, as it was changed for a long time, like over 30 or 40 years, that for planting in some site, people doesn't realize this is planted area. You know, that's one thing that in our question that. Okay, we need to prove that in between those sides. And also we have a challenge of using the satellite data, but with the in situ data, how we connect with that. So some people from Burapha University help us for the GIS and remote sensing, because we have no not good expertise about that. This is between 3 university and the government organization also, and of course the building capacity. What we have done is like, yeah, of course, when we collect data, try to do the core sampling in the mangrove and the seagrass area, and also compare the carbon that they can capture in sediment and the biomass, and also let people go together with us in the field, the local school and the local people, and try to make it, how to say, more impact with the one that we can show the industrial or the government that, okay, this is a result that you can use. Okay, something like that. This is one project. So another project that, oh, sorry, I'm missing this. It's actually, there is some worse event that you may heard about the color bleaching and the disease after color bleaching. That is all globally, but I'm not sure this is in regional problem or it's only in Thailand along the Andaman side on the some 3 or 4 states in southern Thailand. We are facing to the loss of a huge area of the seagrass, which is actually the people, even the researcher in Thailand belongs to each university that doing on marine science, try to group together to help to find what is the cause, but it's what kind of accumulation from overfishing also, because people go and catching the kind of gastropod in the sea cat, that for a long time, but it's traditional. But once it's become industrial, the gastropod become high price. So people just keep on keeping, but they use the traditional kind of dredging, something like that. So it's make scratching on the seagrass also. Plus, the thing is dredging of the sedimentation is always be a problem and polluted. Plus the climate change. Once I think is the turn point of the trigger that it's become worse now, and you can see that it's not that it doesn't like kind of heat wave make it dry leaf, but it's the kind of a bit disease maybe, or something that affect and make the leaf gone, but the root is still be there. This is happen in the quite huge area, but maybe it's not regional yet, but maybe it's happen, I'm not sure. But I was talking with the Malaysian friend, and he said it's the same thing happen in Malaysia in some areas. So that is a worry problem also. We actually have no forecasting system, but we use the global platform to track the whatever is gonna happen, like prediction. And I would show you another case on the last slide, but this is another project that we're doing on the coral reef, which is you have studied both sides of the sea, and then I think I share you on last evening that we have the coastal community, which is very unique for the Muslim community also, that we're working with them. Okay, and based on my own research, it's actually we try to looking at the mechanism as I told you, and I integrate with my friend that if it's in coral reef and the seagrass or the algae, which habitat or which one is more sensitive, or which is the response, like the respiration, the photosynthesis, or the mechanism like enzyme. And we have also in situ experiment that between switching of the site that polluted and the site and offshore, and then we switch that, how it's happened along the natural change, for example, in the summer, that increasing of the temperature. And we have the lab experiment tank also, and doing the kind of oxygen consumption for the respiration. And yeah, I won't go in the detail. But this is another new aspect in Thailand. I mean, not the new as people know, because the low oxygen and hypoxia is happen in Anugun area, also very big issue of hypoxic and eutrophication. People already know that is loss of oxygen, but the thing is that the deoxygenation nowadays, people doesn't realize much. I mean, local people, but in this area, there is the coral reef that very close to the estuarine in my area, and that was I think last two years we try to install the oxygen and the temperature sensor, which is that's expensive sensor also, but I try to see how it's work during the heavy rain, or sometimes we have flooding in the southern. So we have seen that there is some hypoxic condition in the reef also, which is we never have any data before. So we try to setting up the experiment about that. But talking about ocean acidification and very expensive sensor, Department of Marine and Coastal Resources, they also have monitor kind of that pH in this open sea and in the coastal area. They are connected with the IOC Westpac team, and then that is kind of observing data that we also assess that data and help us to know the condition in the sea. Okay, this is another part that we also need to communicate with the people, but it's actually, you can see it's by your eyes that totally different as the meeting room, for example, and the people that comes. So that's some of the community that they already can, like, they will not accept any of your opinion or any of your guidance, because they already be ready with the many things to work with. But in some communities, very poor and very low, that, and some community want to work, the community that want to work with you, it's not all for sure, but that you need to prioritize and choose and go back again to what their needs. Okay. And that we found that the community that would like to join with us, this is also from the zero level, because they never communicate with the local organization before, and they keep on complaining, like blah blah blah. But we was like, okay, this is our side, and we try to bridge them together, how it's gonna work. So at that time, it was like a lot of efforts, but I and my student, we are trying to do that, and I need to send the boy to participate them, to stay with them for a whole year. And even the people go fishing, people go for chicken fighting, he also participate them and building the trust. So that takes time. But finally, we, like, this is 2 or 3 years that we have success to get real engagement from them, and they become like a volunteer for the local national park. That the side of the national park, they also never go to talk with people, because they always say that no budget, no manpower, whatever. But that is I think that is our duty to do that, to connect them. And after that, we don't need to go anymore. Then it's worked by. It can sustain by, they can sustain by themselves. They can just invite, and okay, you want to join me for any survey, for observation, like that. And I also invite the Department of Marine and Coastal Resources in local center to join them. Among the organization itself, Marine National Park and the Department of Marine and Coastal, they never talk with each other. So that's the things. And for us, we try to just give them like, it's not that scientific, but we try to simplify something that easy for the local tourism and okay, then this is your own area and you're taking care forward, okay? And of course, for the many camps of students that behind the mountain, like we have several areas that it doesn't close to the sea, but the how say it in, I don't want to say in equal, but many monies and project is always go to the school or the coast or the whatever close to the sea, and like a student is far away to the sea, they have no chance to even know what is the career of the marine science, something like that. That this is from the campaign that we would like to let them know. Okay, this is not my project, but it's from Department of Marine and Resource. Okay, thank you. 1 minute. From the ladies, the young lady that she shared yesterday, that I think this is very useful, that DMCR people, they try to make some kind of project we call coral bleaching, and this is the citizen side gathering data from the whoever that go to the sea and can snap the photo. It's like a cold snap in Australia, but sending by if you interested, you can go through the website, and then there is both language, the local language also, and you can just submit by phone or by the browser that, okay, this is, but they have the guidance. This is 0, this is 25, this is 50% of the coral bleaching, and how you can see the bleach coral, dead coral, or living coral, or this is recently dead, something like that. And but this was contributes, I think, since 2010 coral mass bleaching in this world, that people try to gather and have a seat and talk among Thai marine scientists, people, and do the gap analysis, do the lesson learned, what we have the lesson learned of the coral bleaching at that time, especially in Southeast Asia also. And after that, the scientists survey whole of the country, but we help each other. Like, for example, the people from nearby capital area, they have their own study site, but from Southern we have this study site, so we pull the data and share and direct the government and submit to the politic also. But only one page that they will read, you know, that just what you should do, what you should rotate, what is the area of the really sensitive, or you should rotate the tourists, because Thailand is become like over all the time. But we need to let them know how to save in faster response to the social when they try to answer the any channel that blooming of the coral bleaching news, for example. And then after some time, like 10 years, I think this passed through the Department of Marine and Coastal Resources, and they maintains and then becomes the citizen side, I think 5 years ago. Okay, thank you.
So I've been told there is online questions for Martine, so we will take a few of those. I will pass the microphone.
Martini, so Blessing is asking, in the context of seagrass decline, how do you compare pollution to fishing activities in the relative impact? From visual inspection of the images, it seems pollution has more influence than other activities.
Again?
So in the context of seagrass decline, how do you compare pollution to fishing activities?
Okay. It's actually it's not that compared by evidence, but people try to. But now it's ongoing of the proof, you know, of the real cause. But by communication, several meetings among the Thai researcher and the government and the local people just try to input the what is possibility of the cause. But it's like a evidence of the leaf or the measuring of the data in situ. So that is just try to input, okay, this is polluted site, or like that. But still ongoing of investigation until now. And I think more forward, like 1 or 2 years,
Okay.
there will be more result.
Thank you. There's actually a few more questions for you in the chat, which I will ask you to answer in the chat because we're running a little bit late. Okay.
Thanks again. We'll invite Fimaretti Selu from the Ministry of Natural Resources and Environment from Samoa, and she will talk about advancing Samoa's coastal resilience.
Falava, everyone. I would like you guys to do a little activity for me. Just put your laptops away. I need you both of your hands to loosen up the morning. Okay, so put your hands together like this. So this is a tradition in us in the Pacific. So put together, yeah, and then you rub. So mili favela, meaning rub it till it's hot. And when I say patia, you say one clap, patia, patia, patia. And when I say hey, hey, you say ho, hey, 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 hey. Yay. Okay, thank you. Yeah, Talo Falava. My name is Fimaretti, and I am from Samoa. And I will be presenting on some. So before I present, I would like to show a background video of where I'm from and some of the challenges that we face. Yeah, I'm from the community side.
In the Pacific, the ocean unites our islands. Samoa lies in the heart of Polynesia. From here, our voyaging canoes have explored an expanse of ocean, which still sustains us today. It provides our air and our food. The ocean stabilizes the Earth's climate. It is where we play, we work, where we connect, and where we find peace. Pacific Islanders know the sea is vital to our own health because it has always been a part of who we are.
We have been experiencing not only tsunamis, but more frequent and more serious hurricanes. We had one in 2012 that took off roofs of houses and have destroyed our plantations and those kinds of things that we depend on. We are mostly people that just live off the land, live off of the ocean. And so we are, whenever there's this kind of impact, we seriously feel it. Because these are happening more and more in between, we don't have the length of time that we used to have when these kinds of natural disasters happen with more, longer time to recover. So with more frequently, it's getting harder and harder for us to recover. And then what we're experiencing is that waves just wash over. This is our Malai. This is where events take place in our village, and waves wash right over this, destroying the Malai and making the land more salty, less fertile for growing. So we appeal to the international community to help our government find us ways to be able to mitigate this. 20, 30, 40, 50 years ago, the sand was way out there. Now it has just eaten up our coastline. And we're being pressed more and more towards the hills here. So we're now having to reckon with where do we go? Do we go uphill or do we go off island? And so these are some of the issues we're going to be confronted with in the days and years to come.
threats to the coast of Samoa. So these are, to sum up all the threats that we've, that's in the video. So yes, it's climate change, unsustainable developments, for instance, land reclamation, and also coastal development, the disturbance which loses the resilience of our coral reefs and our mangroves, and also the intentional and unintentional introducing of invasive species into our environment. And these are some of the efforts that we're doing to increase the resilience of our local communities. So far, we've been able to establish 9 coral nurseries in the 9 sites of Samoa. So these are the 2 main islands. We've established 5 coral nurseries on the other island and 4 on the main island. So this is how it looked like in the year 2002, the fragments, our coral nursery fragments, and this is how it's going. So as you can see, some of the corals are trimmed, so to be outplanted onto our reef stars. So with the projects that come in, we managed to outplant these coral nurseries to reef stars onto A-frames. So these are what we can afford with the budget and projects that, and we also use cementing method whereby we cement these coral fragments onto our degraded reefs. Not only that, we also do mangrove nurseries with the villages. So the process of this, every community if they have mangroves. If they're interested to conserve the mangroves, they come to the government, to us, they bring in a proposal, and then we go through this list. So whatever project that comes in, then we distribute these projects to the village. So the first villages that comes in is a priority, or the priority are the most vulnerable communities. So we establish mangrove nurseries using the direct method of planting. We just plant them in. And the Tongo bag method, which is now a pilot method in Samoa, which we try to stabilize our seawall. So we have rock seawalls, and so this is a pilot. So we were trying to see if it's successful, and so far we've seen the growth of these mangroves, and we hope it'll stabilize our seawalls. And yes, there's also waste audits and coastal cleanup. And yeah, the reason why I put up our turtle nesting surveys, it's because as we all know, our turtle nests plays a great role in improving the fertility of our sands and improving our coastal plants so that they can grow better. And then we also go into the communities and do awareness programs and hands-on training. So when it was mentioned, the zero approach, where everyone is involved from the beginning. So this is one of the method that we use to engage the community from the beginning of the project, is to let them come and join us as we do so then that we leave the communities and they continue on the work themselves. But we always come back every 3 months and help them with the monitoring. And this is one of the strategies and policies. You can go into the link and you can find all the other strategies and policies that we've developed, such as the Marine Spatial Plan or National Adaptation Plan, and all the other scientific plans that are available. Yeah, some of the challenges to these efforts. Yeah, coastal erosion and sea level rising, as I explained, and also marine. So two of the challenges that I like to highlight is the community commitments. Sometimes when we take these projects back to the communities, the commitment from the communities are not good, so that they don't take ownership of the projects. And it's a challenge for us to sustain the projects with the community. Sometimes we train the people and then we come back and they're already working somewhere else, or they've gone for seasonal working. And also staff turnover. So we train people in the government, and then of course when opportunities come and they just want to leave and leave with the capacity that they're already built with. So those are the two main that I wanted to emphasize on. A way forward. So, one of the way forward is we're looking at establishing a coral reef and mangrove monitoring framework, where, because as of now, we don't exactly know the status of coral reefs in Samoa unless because the sources are very separated, that we have to gather these sources and do this. But it's very good if the government has a framework whereby they do monitoring every 2 or every 3 years. Yeah, so that's the way forward. And even with mangrove monitoring, we do monitor. We do research and monitoring when we go back to the communities in terms of mangrove audits and letting the communities know what is available with their mangrove areas. But there's still a lack of knowledge in that area. Yeah, we are looking at also the expansion of these projects through securing more funds. Capacity building, yeah, so there's really much a need in the increase of the capacity of our staff, especially with the staff turnover problem. We need to increase every time. And looking at new methods. So as of now, we don't do, I'm very grateful that I'm part of this workshop, so that it opened my eyes that there's more out there to do with what we can, with the modeling and everything. So it's very good to look at these new methods in order to inform us of what is available around there and what we can do to improve our coasts. Yeah, that's it from me.
We have time for one question.
Thank you. Do you have early warning system in your country?
Sorry?
Early warning system, such as you say there's a lot of cyclone in your country.
Yes.
Do you have early warning system?
Yes, we have an early warning system, but it's a different division from my ministry that does it. It's the disaster management office that does the early warning system. Yes, but we do have early warning system.
How does it work?
So every time there's a tsunami, we have sirens that. No, not tsunamis, like warnings of earthquakes. So we have, sirens all around, especially on the coast that's vulnerable. There are sirens available for whenever it comes up. And we also have drills when it comes to emergencies, such as those. Yes.
Okay, I think, yeah. Sure.
Hello, thank you for your presentation. I think all islands have similar challenges, so I definitely identify with some of the constraints you have to find a way to deal with. What have you all considered to put in place for legacy and continuity, given, when persons get opportunities and they leave? Because I mean, we're happy that they get opportunities there. We're like, yes, great. But, then you're left with that gap. What do you think can be done to try and ensure, turnover or whatever when somebody else comes in?
So one of the ideas that we've been talking around is to have that framework. So in order to have that framework, so then we can be able to provide at least incentives because that's some of the concerns raised by the youths in the communities. Why should we do that if we aren't getting paid? So that's the mindset that they're having. So we are pushing forward to let them take ownership of the project, and especially as mentioned by Abe, letting them involved from zero. Yeah, yeah.
Great, thanks again. And we now move on to our final presentation, which is online from Hadir El Kouli from Egypt. and he will talk about empowering ECOPs to drive crime resilient costs through community conservation.
صباح الخير everyone. صباح الخير, good morning, buongiorno. I hope you are all doing well. Just 1 minute, I will share my presentation. Is my voice clear and you can see my slide now?
Go ahead.
Okay. My name is Hadir Ahmed Al-Kholi. I am from Egypt and ECOP, Africa Communication Lead and Media Coordinator. And my background is sustainable aquaculture and fisheries management. And today I will talk about empowering ECOPs to drive climate resilient costs through community conservation. But before I start my presentation, let me take I standing on the beach. Faces were filled with hope, but as they empathize their catch, the reality struck me. Among the fish were
Excuse me, Hadir. Could you please close the camera because the sound goes a bit on and off? Hadir, can you hear me? Hadir? Technical problems, I think she dropped out of the call. So a moment of patience.
I'm sorry. Let me share.
Oh yes, I was saying if you could maybe close the camera, then the sound will be better.
Yeah, I'm sorry because the power here is cut, so I'll try to. I'm really you, but as they empower me.
The quality is it's really hard to
The fish were the
understand.
broken shine. One fisherman. Good now?
Now it sounds better. Do you want us to share the screen? Is it maybe easier?
My sound is good now?
It is, yeah, quite good. And if you want, we can share the presentation for you.
My presentation is okay now? One fisherman turned to me and said, the ocean give us life.
كلام تمام كلام تمام مستمر ايوه كلام تمام
My sound is good?
Yes, the sound is good, but we would like maybe to share your presentation for you, so then you can just use your audio. Can we do that? Can we share for her? Yeah, okay. Okay, please go ahead.
I'm sorry. Okay. Okay. One fisherman turned to me and said, "The ocean gives us life, but who take care of the ocean?" That question has stayed with me ever since, reminding me of the responsibility we all share in protecting our coastal region. And now I want to talk about that our coastal communities are at the front line of climate change through different vectors like rising sea level, extreme weather, pollution, which threaten their way of life. But today I want to talk about hope, about the power of individuals, especially early career ocean professionals, to drive real change. And now, who are ECOPs and why do they matter? ECOPs are more than just young professionals. We are scientists gathering crucial data, engineers designing innovative solutions, conservationists protecting biodiversity, and communicators spreading awareness. And together in this process, we are the bridge between science and society, bring knowledge, technology, and action to coastal communities that need it most. And but let's be real, making an impact isn't easy. ECOPs face three major challenge: funding and resource. Without financial support, many brand conservation projects remain just ideas. And another thing, we face policy engagement because our work must influence decision makers, but breaking into policy decision is tough. And another thing is community trust. Local people are the heart of conservation, and yet building trust takes time, effort, and collaboration. Despite this challenge, we have a lot of opportunities. We can monitor ecosystem to track climate impacts. We can restore damaged habitat from coral reef to mangrove. And we can integrate local knowledge, recognizing the wisdom of indigenous communities. And most importantly, we can inspire action, ensuring that coastal protection is not just a scientific effort, but a community movement. Um, and now I want to talk about communication conservation as a solution. The most successful conservation efforts are those led by the people who depend on the ocean. But when we deal with them as a partner, not beneficiaries, when we empower local fishers, indigenous groups, and coastal residents, we create lasting change. And by working alongside ECOPs, communities are not just receivers of knowledge, but active participants in ocean protection. So now, why empowering ECOPs can make a great impact? So, what do ECOPs need to become effective leader in coastal resilience? They need leadership to up their skills to lead conservation projects and advocate for policy change, and they need investment in initiative idea and research, and learn how to communicate, collaborate, and earn trust. There are a lot of case strategies for success, like ensuring everyone has a role to play, and the solution should be designed with not just for communities, and we must empower local people to sustain conservation effort beyond our involvement. And now I want to share case studies in different regions in Africa, from ecosystem restoration to capacity building to ocean literacy program and educate children, and another project impact assessment that track success of different models, and how we can measure impact. And now we have project, we have ideas, and now how we can measure impact and scaling successful models. We can scaling up success like replicate success conservation models, sharing the idea between us. And the important thing we lack in every process we have data collection. It is the most important thing in to collect data on ecosystem health, community well-being, and project outcome, and evaluate the effectiveness of conservation project in enhancing climate resilience and biodiversity. Before I finish my presentation, as I said, who take care of the ocean, the answer is us. Each of us in this room has role to play. Whether you are a scientist, policymaker, or community leader, your action matter. It is time to work together as a partner to ensure that our coast remain resilient and safe for the future generation. And thank you, shukran, gracias. And before I finish my presentation, also I would like to express my gratitude to the dedicated collaborative center for coastal resilience and to everyone who gave me this opportunity to be part of this event today. And also once I was once physically among you, technology has made it possible to stay connected across distance, and this reminds us that even the smallest action, when initiated at local level, have the potential to create global impact one day.
Thank you very much, Hadir, also for joining online. Are there any questions from online or from the audience here? Okay, well, I guess people need a break. So thank you again, Hadir. And do we want to do?
Thanks a lot. And if you have any question, you are welcome. And
We
really,
just
really
have
very
one
sorry.
Slido question, and then we
electricity.
can go to the coffee
Yes,
break.
okay.
So I will pass the
Okay.
word to Abe for that.
Thank you, everyone. Yes, after yesterday, probably we need more breaks. But before that, we'd like you to do a little bit work. Just 2 minutes. Give us some words. No, yes, and no. Yesterday, we have a big yes. I think the yes is for drinking. But yeah, just give us 2 minutes. Huh? No active poll. Active poll, please. Yeah, I think one of the challenges also handling a workshop online. So probably next time we can improve a little bit by pre-recording it, and then they can take questions. That is also another strategy next time. I apologize for it's a bit yeah, but we hope, of course, next time everybody can come. That is the best to create trust among us. Yeah. So is it okay? You can bring your questions to coffee, answer while you are waiting for your espresso, right? That is, huh? Posters. Only one question. And go around the poster as well. And we have a short poster talk also afterwards. It's okay. Okay? So let's gather back in 15 minutes. That meant 10 what? 10:50. 1050. Right? 1050. Thank you very much.